Hey guys, how's it going? This is Carl again. This is problem number 8 for session 9. It's kind of a little lengthy in kind of terms of theory, but just going to go ahead and get started. Researchers collected samples of water from streams in a mountain range to investigate the effects of acid rain, and they measured the pH, or acidity as it's called, of the water and classified the streams with respect to the kind of substrate, the type of rock over which they flow. A lower pH means the water is more acidic. A plot on the right shows the pH streams by substrate, limestone, mixed, or shale rock. Selected parts of the software analysis comparing pH of streams with limestones and shale substrates are shown below. In parts A through C, so two samples t-test is mean 1 minus mean 2 equals 0. Difference between the means is 0.735, and the t-stat is 16.3 with 150 degrees of freedom. P is less than or equal to 0.0001. So, state the null and alternative hypothesis. So in this case, the null, which is, as you know, specifies population parameter and proposes the values for that parameter. The alternative contains values of that are considered plausible if the null is rejected. So notice that the two sample t-test looks similar to mean 1 minus mean 2 equals this value. From that we can determine that the null is mean 1 minus, or L minus of S equals 0. The alternative hypothesis is then that this same equation does not equal 0. So it's very similar, as you can see, and that's basically kind of showing, is there a difference between the two? So it's kind of giving information that we're extracting and trying to figure out what would be the alternative and the null hypothesis in this case. So moving down to B, from the information, are the conditions, do the assumptions and conditions appear to be met? So before performing a two-sample t-test, 3 conditions must be checked. The data in each group must be drawn independently and at random from its own homogeneous population, or generated by a randomized comparative experiment. Next, the data in both groups must be approximately normal. And finally, the 2 groups must be independent of each other. Check to see if this data is given these specific conditions and describe the independence assumption for this situation. So it is unknown, first off, that the streams are chosen randomly. Assume that the pH of one stream does not affect the pH of another. There's no cross-pollination, or in study terms, there's no contamination. Study contamination, literally. So describe the normal condition for this. Kind of moving down. The box plot shows that the pH levels of the streams may be skewed and that there are outliers. However, there are 150 degrees of freedom. So these sample sizes are really quite large. And describe the independent group assumption. Well, the pH levels from the 2 types are independent, which we've said that before. They do not interact. There's no interaction that's known. Therefore, all the conditions are satisfied. So just going back up, you can see how that there is a skew in terms of the limestone and the pH value. So just keeping that in mind as we're going forward. All these conditions have been met. So what are the conclusions? Well, the p-value is the probability to which you can base your decision to prove or disprove, or to reject or fail to reject the null hypothesis in this case. A low enough p-value says that the observed data would be very unlikely if the null hypothesis were true. When the p-value is high, or just not low enough, the data are consistent with the model from the null hypothesis, and there is no reason to reject the null hypothesis. So note that it is given in the problem that p is less than or equal to 0.0001. So in terms of our decision, our t-stat, so if the p, because your p-value is so low, as it's noted here, and remember this statement and clause, it's very unlikely that the null hypothesis were true if it's a low enough p-value. So that means that we reject the null based off of this. So we reject this null hypothesis right here, that this always equals 0. The differences between the mean will always be 0. It's not the case. You can tell graphically, you could tell quantitatively. So this is just kind of a good breakdown in theory